Continuity of a piecewise function. Here is actually a very difficult example. I have found this in the test many times, and well, people do start it correctly but can't really find the real value of c. Okay, let me first read the question. The question says, for what value of c is the given function f of x continuous on the entire domain? And the function is f of x equals to cx minus 1 whole cube, where x belongs to minus infinity to 2. 2 is not included here, right? And the other half is c square x square minus 1. X belongs to from 2 to infinity, where 2 is included, right? So that's the function. Now individually, if you see, this is a cubic function, and this has to be continuous in its entire domain, which is from minus infinity to 2. So that part is continuous. And after 2 also the function is continuous because square function, right? Another polynomial, correct? Polynomials, you know, are smooth curves with smooth continuous curves, for us more important, right? Now, entire domain, because it is from minus infinity to plus infinity, right? The only place where this could be discontinuous is where the piecewise functions are joined together, and that is always the place where the piecewise function could be discontinuous, correct? So where they are joined together, especially in the cases when we have all the pieces as polynomials, right? No other places there. So what we do is, so that basically tells us that what we need to do here is that at x equals to 2, the two parts should match, right? Pieces should join together. Have same value, right? Correct. As you can see, what really happens is this part includes, right? This part doesn't include. So this part gives you a whole, right? And let's say the other part gives you the starting point in this. If these 2 points are separate, then they are not continuous. But if this part joins in and it is at exactly the same place where you have the whole, then it becomes continuous. And that's what we mean to say when we say pieces should have same value at x equals to 2, correct? So now what we do is try to solve, writing our equation, right, for both the pieces with x equals to 2. So now if x equals to 2, then the first half gives me 2c, because x is 2, so c times 2 is 2c. It's better to write the number first, right? Minus 1 whole cube, correct? This should be equal to, when I write x as 2, 2 square is 4, right? So you get 4c square. So we get 4c square minus 1, correct? So this is from the second half, and this is from the first piece, correct? First piece, the value gives kind of a whole, and this gives us the starting point. And if this plugs in the whole, then the two pieces will join together and the whole function will be continuous in the entire domain, right? Now to solve this problem, one caution is don't expand it. Do you see some similarities here? If we expand, simplify, it may take a lot of time to solve this kind of a question, right? So what I will do is I'll try to use these factors themselves. Here this looks like a difference of squares. Do you see? It is like 2c whole square minus 1 square, right? So I can factor this. So what I will do is I'll bring them together and then try to solve it. So the trick part is here, and I bring it on this side, so we get minus. So I can write this as 4 square minus 1 for the time being equals to 0, right? Now this could be factored, right? So I can write this as 2c minus 1 whole cube minus, this could be written as 2c minus 1 times 2c plus 1 equals to 0. Do you see that part? So we can factor it because we got 2c minus 1 common. Do you see that part? So we get 2c minus 1 common, and in the bracket we are left with, here we have 2c minus 1 square because we took one of them outside, and here we have already taken 2c minus 1, so we get minus of 2c plus 1. Is it okay? Equals to 0, correct? Now these are the two factors. We already got one value of c, right? So if this is 0, that is c equals to half, we get a 0, correct? Well, that's the first value. But I think we'll have to simplify the center part also and see how do we do. So now from here we can just move on to this place and take this, copy this here, and simplify, expand and simplify the center portion. So we are left with 2c minus 1, and within bracket I'm expanding this, so it is like a minus b whole square, right? So we get 4c squared. 2 times these terms becomes 4c with minus sign because of this minus, plus 1 square, which is 1, right? And then we'll open this bracket also. So minus 2c and minus 1, right? Minus 1, and this is equal to 0, correct? Now again, this implies that we have 2c minus 1, and here we'll combine the like terms. So we have 4c squared, and minus 4c and minus 2c makes it minus 6c, and plus 1 and minus 1 makes it 0, right? So we have this equal to 0, correct? Now here we can factor this further. So we get 2c minus 1, and this we can factor. So we can take 2 common, right? 2c common. I didn't have any space, so let me write 2c here now. So we can take 2c common. If I factor out 2c, then I'm left with 2c, right? 4 divided by 2 is 2, and c squared divided by c is c, minus 6 divided by 2 is 3, right? So we get this equals to 0. Perfect. Now we can rearrange. It's better to write this term first, and so we say it implies 2c times 2c minus 1 times 2c minus 3 equals to 0, correct? So that's what we get. Now these are 3 factors. So for getting the solution, what should be the solution? Either this could be 0, correct? So either one could be 0, yielding different values of c. This could be 0, this factor could be 0, or this factor could be 0, right? So when we write 2c equals to 0, we get c equals to 0, right? But when we write this factor 2c minus 1 equals to 0, so we get c equals to 1 goes that side and we get half, correct? And when we write 2c minus 3 equals to 0, then 3 goes that side, then divide by 2, we get c equals to 3 over 2. Is it okay? So these are 3 different values for which the function could be continuous, correct? And now we can write down our answer, and that is c equals to 0, or c equals to half, or c equals to 3 by 2 to make this function continuous, correct? So I hope you appreciate what we did here, and that makes it very neat. Otherwise, if you expand, you can use a minus b whole cube formula here, expand, simplify, refactor, and do your thing. But you know, cubic equation factoring is kind of tricky, right? Okay, I hope you appreciate it. Thank you.